Hello everyone, welcome back to Riemann sum, lesson number 10 for BC Calculus. In the first video we talked about a left Riemann sum and a right Riemann sum, and so I went ahead and just drew the rectangles for the left and right Riemann sum from what we talked about before. We look at the chart that we're given here, and we've noticed that from each of these, our difference is going to be delta x, it's going to be 0.5. So from 1 to 1.5 is 0.5, 1.5 to 2 is 0.5, 2 to 2.5 is 0.5, and then 2.5 to 3 is 0.5. So I know that right now delta x is going to be equal to 0.5. The other thing is I've got one rectangle, I've got two rectangles, I've got three rectangles, and four rectangles. So what I could have also done to find delta x was the formula that we used before, that we're on the interval from 1 to 3, and we want four rectangles. So I could do 3 minus 1 all over 4, and then I get this is 2 over 4, which is also going to give me 1/2. So this is another easy way of doing this problem. And so I want to say that delta x is actually constant. So for our left and right Riemann sum, we're going to use the shortcuts, right? And then we'll talk about the midpoint and the trapezoidal one in more detail now, after I do this actually. So for the left Riemann sum, we're going to go ahead and pull out the 0.5, right? And then we're going to add the left numbers. There's 5 y values here. And remember, it's just the heights of our rectangles, right? It's the heights of our rectangles. So we use the height at 1, 1.5, 2, and 2.5. So we use the ones that are to the left. And so we're not including 10. So we're going to do 2 plus 3.25 plus 5 plus 7.25. And then we're going to get that this value is 8.75. So the approximation for this Riemann sum of the curve from 0 or from 1 to 3 is actually approximately 8.75. We also know that it's an underestimate, right? We know this is going to be under because our function is strictly increasing, and for a strictly increasing function, our rectangles on a left Riemann sum is always going to be underneath the curve because we did not incorporate these 3 little triangle-ish looking things right here. All right, so let's do the same thing with the right Riemann sum. So for a right Riemann sum, I'm going to go ahead and put the work down here. We're going to go ahead and factor out a 0.5 because, again, it's constant. And we will do examples where it's not constant in a little bit. And now notice that for the right Riemann sum, all of our heights are going to be on the right. So 3, 2.5, 2, and 1.5. So now I'm going to use the rightmost numbers, and I'm going to add those up. Sorry, that's 3.25 plus 5 plus 7.25 plus 10. And when we add that up, we're going to get approximately equal to 12.75. So we know that the actual area underneath the curve is between these two numbers. Now, not the midpoint of these two numbers, not directly in between them, but somewhere in between this range, right? So 8.75 and 12.75. So now let's talk about midpoint. Let's talk about the midpoint method. So one thing that we can do based on what you just see up here is if I start at 1 and I go to 1.5, right? If I do a midpoint, what's going to happen is that between 1 and 1.5, I want to actually go midway to it, right? So I'm going to go halfway up between 1 and 1.5, and I'm going to create a rectangle that looks like this. So some of it's outside of it, some of it's inside. It's really hard to actually see with this color, but that's exactly what you see here is that you go midway up, we go here, and then we go ahead and create a rectangle this way. What we have an issue with this is that we are looking for the height of this thing. Well, the height of this thing is going to be what is f of 1.25. We don't have that in here, right? We don't know what that is. So what we could do is we could be given an equation where we can plug in 1.25 and find those values, or we can do another method. And another method is, instead of going and looking at the delta x being 0.5, let's go ahead and change it and make this 2 rectangles. Let's do 2 rectangles instead of 4, and they're always going to tell you how many rectangles we're going to do. So we're going to do 2 rectangles. So I want one from 1 to 2, and I want one from 2 to 3. And so what's the point of that? How does that help us? Well, that helps us because between 1 and 2 is 1.5. So I'll come up here to 1.5, and then I go ahead and create myself a rectangle. And I already know what that height is, right? I know the height of this thing is going to be 3.25. So I know this distance is 3 1/4. And so I can go ahead and do the same thing with this one. right? I go halfway up, so between 2 and 3 is 2.5, and then I can go ahead and create myself a rectangle like this. Now, like I said, guys, they're going to tell us how many rectangles we're going to use. So for this one, we're saying we're going to use 4. Here, we're going to use 2. We have an equation. If we have an equation, we could absolutely use 4 to find these problems as well, but right now we're just going to do that. As long as you guys are okay with how to draw them. So what is the delta x in this case? Well, again, it's going to be 3 minus 1. This is what delta x is going to be equal to, right? Delta x is going to be equal to 3 minus 1. But now we only have 2 rectangles instead of 4, so this is going to be 2 over 2, so delta x is going to be equal to 1. So that's what we need to know for these questions. So for this problem right here, my delta x is 1. And again, I'm just finding the area of this thing. And I know that the height of this is going to be 3.25. 3.25. And then I'm going to add this rectangle right here. Well, again, my delta x is going to be 1. And the height is going to be in between 2 and 3. It's going to be 7.25. And so I'm going to add these numbers up, and I'm going to get the actual value for this, which is going to be 10.5. Okay, 10.5. So that's a good way of looking at approximation of this. And so we know that that's in between these two things. Notice that it's not the midpoint of these two numbers. So the midpoint method gives us 10.5. One of the things that students always get wrong or incorrect is they think that it's going to be this right here is going to be the average of these two right here. The left and right average is going to give you the midpoint, and that's not true. If you add 8.75 and 12.75 and you divide by 2, you actually get 10.75. They're pretty close, but they're not going to be the average. Okay, they're not going to be the average. So let's go ahead and actually now get into the trapezoidal method. Okay, so now we're going to talk about the trapezoidal method. And so what we're going to do with this one is we're going to draw trapezoids instead of rectangles. So for the first 3, we've talked about rectangles. So I went ahead to save some time and put the points down here from the chart. And so we're going to look at the interval from 1 to 1.5. And so we're going to go ahead and do this. And we're going to go ahead and create a trapezoid. So this will be one of our bases here, and this will be our second base. And then we're going to go ahead and connect these tops. So it's going to look very similar. It's not exactly, because this is still a curve and this is a straight line right here, but it's going to kind of feed into the line pretty well. So there's our first one. So our first trapezoid is between the intervals of 1 and 1.5. And then we're going to go ahead and do the second one between 1.5 and 2. So all you're going to do is you're going to go ahead and 1.5 to 2, because our delta x is going to be equal to 1/2. We're going to have 4. We're going to have 4 trapezoids. Again, they will tell us how many we're going to have. And then I go ahead and I follow up to the line here. I follow up to the line here. And then I go ahead and just connect these with a straight line, like so. I do the same thing with this, 2.5. I follow the line up. I follow the line up. And again, I draw myself a straight line. And then I do it one more time. So 3.5, I follow it up. I follow it all the way up. And then I draw myself a straight line. And that one's not looking so good, but it's okay. So those are our trapezoids. Now again, ladies and gentlemen, there's going to be some shortcuts we can do here because delta x is constant. So let's just really quickly say that delta x is actually equal to 0.5 here, and the fact that it's constant. So I'm going to show you how to do it without the shortcut, and then I'm going to show you guys how to do it with the shortcut. The only other thing that we need to know on this problem is that the area of a trapezoid is 1/2 the height, and then multiplied by the sum of the bases. Okay, so if you guys look at these trapezoids down here, if you look at these actual trapezoids, you would see that if I turn one over onto its side, so I'm going to do a 90-degree clockwise thing, and I were to look at it like so, right? So I just took one of these and I turned it 90 degrees clockwise. Notice that the height's actually right here, right? And then this is base 1 and this is base 2. So for trapezoidal, our height is going to be delta x, right? This distance here is going to be the height. And the base 1, is going to be what one of your heights is of your trapezoid, or your distance between, the x-axis up to your curve. And then the other base is going to be the other distance from your x-axis up to your curve. So if I want to go ahead and look at these trapezoids, I can go ahead and start adding these sums up. So this is going to be our purple one. I'm going to call this 1. So trapezoid 1 is going to be 1/2, and I'm just following the formula here. Our height will always be our delta x, so our height is going to be 1/2. And then we're going to add the base 1. Base 1 is going to be this distance right here. Well, this is the y value at x equals 1, right? It's the y value at x equals 1, which is going to be 2. and I'm going to add to that the y value of our base right here. So this is going to be the y value of 1.5, which is going to be 3.25. So that's going to be our very first trapezoid. And now I'm going to go ahead and do trapezoid number 2. And so this is going to be 1/2. And again, this 1/2 comes from the fact that it's part of the formula. And then my height, again, is going to be 0.5 because that's what delta x is. So again, this is replaced as delta x. And then my bases, well, my base, and they share a base. So my top side of trapezoid 2 is going to be the y value at 1.5, which is 3.25. And then the bottom base, again, if I were to rotate this clockwise 90 degrees, would actually be the y value at x equals 2, which is going to be 5. And so, guys, just very easily, if the delta x's are not constant, this is what you do. This is exactly what you do. You just have to manually go in here and just actually find them on your own. So there is a shortcut, which I'm going to show you guys in a second, where if delta x is constant, you can do something. And I'm going to use this right here to help you guys with that. But yeah, if delta x is not constant, then you do exactly this. You just literally draw the trapezoids and you just kind of think about what you need to do for it. Okay, so back to trapezoid 3. So my top base is going to be where x is equal to 2, which again is going to be 5. And then the bottom of your base is going to be where x equals 2.5, which is going to be 7.25. And those are the heights, right? This is this distance right here, 7.25. And then the last trapezoid, right, trapezoid number 4, which looks hideous, right, it's going to be 1/2 again for the 1/2. The 0.5 is the delta x. This height is going to be 7.25, again, where x is equal to 2.5. And then our height over here is going to be at x equals 3, which is going to give us 10. And we're going to add up all of these numbers. We're going to add up all of these numbers here with our calculator, and we're going to get a 10.75. 10.75. Okay, so a couple things I want to talk about with this. But first of all, let me just go ahead and say this before I forget to say it. I will tell you guys that the trapezoidal method will give you the average of these two things right here. So if you take the left hand Riemann sum and you add it to the right hand Riemann sum and you divide that by 2, you're always going to get the trapezoidal Riemann sum. Okay, so the average of the two is going to be your trapezoidal Riemann sum. So that will always work out. That will always work out. So that's the first thing. What is the shortcut for this? So what is the shortcut that we need to do for this question? So if delta x is constant, okay, then what we can do is we can pull out a couple things. So the first thing we can do is we can pull out a 1/2 for this, right? They all had a 1/2. So I can go ahead and pull out a 1/2. And then the other thing I can always pull out is whatever delta x is. Okay, whatever delta x is. And so, again, it's 1/2 here. And then notice, ladies and gentlemen, that what did we add? So now we got this, and this already pulled out, right? We've already got it pulled out. So notice that we have a 2, and then we have 2 3.25s. We have 2 5s, and we have 2 7.25s. Because, again, trapezoid 1 and 2 share a common side. Trapezoid 2 and 3 share a common side. And trapezoid 3 and 4 share a common side. So rule of thumb is this. You're going to always have your first number, and then you're going to do 2 times all of your middle values, and then we're going to add the last. So let me show you what that means here. So this is going to be your formula that you're going to do for this. So what do I mean by this? So if we go back up here to the table for a second, and let's do the trapezoidal right here. I'm going to go ahead and do the 1/2 because of the trapezoid. I'm going to go ahead and do 1/2 because of delta x. And then my first number is 2. So I'm going to write a 2 here. And I'm going to plus 2 times everything in the middle. The sum of the ones in the middle. So it's going to be 2 times 3.25 plus 5 plus 7.25. I apologize that I'm writing over these words here. So it's just this plus this. This is probably the easiest way to do it, right? It's probably do it this way. And then I've got to add the last one because only one trapezoid shared the side of 2 and 10. And so this value right here is going to also give you your 10.75. All right, 10.75. So that's our shortcut for the trapezoidal. That's the shortcut for the trapezoidal. It says write the integral that represents the actual area under the curve. So what this means is that we're going to, we're going to talk about this in the next lesson, but the integral looks like an S for segment notation. We were on the interval from 1 to 3 of our function. and then delta x. And I'll talk about more so about what this is and this is a little bit later on. So this is what our actual function is. And then we were actually given an equation in the note set that I didn't show of what this curve was. So I'm going to go ahead and write down what this formula is right here. And the formula was x squared plus 1 delta x. And again, we'll talk more about this a little bit later on in the next lesson. But that's the function. If you were to actually use your calculator to do this, so let's show that. Plug into your calculator, you can go math, and then you're going to actually go to math 9. So math 9 actually helps us with this. And so we're going to go ahead and integrate this from 1 to 3. And you're going to learn how to do this by hand in the next lesson. But 1 to 3, and then we're going to type in our function, which is going to be x squared, right? X squared plus 1. And then we're going to go ahead, and this will always be our value. In this case, it's going to be x because we're in a rectangular coordination here. And we're going to go ahead and do this. So our actual area under this curve for this function on the interval of 1 to 3 is going to be 10.667. So it's going to be 10.667. So based on what we did here, the trapezoidal method is actually the best one. All right, that was actually the closest one to it. Now, I will tell you guys right now, if we had went back and plugged in values and figured out, okay, and did 4 rectangles here instead of 2, midpoint would have given us the better one. So if we actually went and done that, and we could have easily did that now that we know the function is x squared plus 1. But it doesn't really matter. You will always be asked to find whichever one that you want to do. So for this example, it's the trapezoid. And then, just like before, we talked about, which one's an over versus under estimate for the left and right Riemann sum. So now let's talk about the midpoint and the trapezoidal one. So let's talk about that one for a second. So this is the easiest way for me to tell you guys this, and this is what I tell students, and this is probably not the best way to do it, but this is what I say. I tell students that if you have an strictly increasing, right, and then what's really important here is not has to do with increasing and decreasing, it's the fact that it's concave up. Okay, so it could be concave up, strictly increasing, concave up, strictly decreasing. It doesn't matter. It doesn't matter if it's increasing or decreasing. What it matters is that it's concave up. What I tell students to do is that you always connect the endpoints of your figure, and then you're going to go ahead and create yourself a trapezoid. So for both these examples, I go ahead and connect my 2 endpoints, and I create myself a trapezoid. So notice for concave up, this trapezoid is above, right? It's above the curve. So therefore, I know that the trapezoid will be an overestimate. If I were to look at concave down, and it doesn't matter if I'm strictly increasing or decreasing, if I'm concave down, I do the same thing. I connect my 2 endpoints, and I go ahead and create myself a trapezoid. I connect my 2, and I go ahead and create myself a trapezoid. So if it's a concave down, then I'm going to be an underestimate. And then I always tell the students that, that the midpoint is going to be the other one, right? So just like with when we're strictly increasing, right, left Riemann sum is going to be an under, and a right Riemann sum is going to be over. Well, then if a trapezoid is an underestimate, then a midpoint's going to be, if a trapezoid is an overestimate, then the midpoint's going to be an underestimate question. And you guys can kind of see that right here too. If I'm literally in the middle of the thing, then the area that is here is going to be a lot less than the area that's right here, right? The area right here. So this area is going to be smaller than that one. But on the flip side of this area right here, if I'm midway to it, right, this area here is going to be much bigger than this area is right here. So it's going to be an overestimate. So I tell students for this one, you do have to remember that we're looking for concavity now. So strictly increasing and decreasing is for right and left Riemann sum. Concavity is for midpoint and trapezoidal. And like I said, ladies and gentlemen, I just tell students to just go ahead for trapezoid. Just, and like I said, not the best method to do it, but go ahead and connect your curve and create a trapezoid. So here's your part of it. And then just see, is this area, because we're looking for just the area under the curve, right? So this area is much less than the area that you actually want in the trapezoid. So that's the easiest way to do it. And then the midpoint is going to be the opposite of that. So if this is going to be an overestimate, then your midpoint is going to be an underestimate. But you could also graph, if you wanted to, you could graph, this. But it's just hard to gauge, in my opinion, how you graph it. Like, okay, which one of these actually does have, the bigger area? So I just tell students, just the trapezoid one's easy to do. Just know that the midpoint is going to be the opposite of that. Okay, so that's how we're going to finish this video. We've now talked about midpoint and trapezoidal. In the next video, ladies and gentlemen, we're going to actually start talking about some examples and show you guys how to do them. So come back in the next video and we will continue on with Riemann sum.